Assalamualaikum and hi everyone, this is Dr. Shazira, and in this video I'm going to show you how to find a root of a nonlinear equation by using the bisection method but without memorizing the algorithm. You need to recall two things. The first one, in the graph, the root is marked by the intersection point between the curve and the x-axis. And number two, in the bisection method, the interval is divided into half at each iteration. Look at this example. Use bisection method to determine the root of a nonlinear function fx equals x cubed minus x squared minus 2 on the interval 1 and 2. And the stopping condition is the absolute of fci must be less than epsilon, where the epsilon is 0.005. Okay, recall that the formula for the midpoint is Ci equals Ai plus Bi over 2, where I is the iteration number. Okay, so let us start with the first iteration, that is when I equal to 0. Okay, so when I equal to 0, we have A naught. Okay, A naught equals 1, which is our left interval, and B naught is 2, which is our initial right interval. Okay, and then with the formula C, then we have C naught equals A naught plus B naught over 2, which is 1 plus 2 over 2. So we have here 1.5. Okay, and then we need to get FE and FC. So FE, which is A naught, FA naught is F1. So you plug in, okay, in the equation of F, okay, with x equals 1. So you have 1 cube minus 1 square minus 2. So we have negative 2. Okay, and then we compute for FC naught. So FC naught is F1.5. So similarly, we put x equals 1.5 in the equation of F. So we have 1.5 cube minus 1.5 square minus 2. That will give us negative 0.875. Okay. Okay, note that the absolute of FC naught, okay, which is F1.5 is 0.875. So this is way greater than the epsilon, okay, which is 0.05. So it means we need to proceed with the next iteration. Okay, but I'm going to show you graphically first. Okay, okay, now we have this y-axis and this is x-axis. Okay, now our A naught and B naught is 1 and 2 respectively. So somewhere here is your 1 and this is your 2. Okay, so in between we have C naught. Okay, so let's put somewhere here is our 1.5. Okay, now when x is 1, the corresponding f is negative 2. So we have, okay, just assume somewhere here is negative 2. So when x is 1, you have f is negative 2. So we have that point. Okay, and then when x is 1.5, okay, so the corresponding f is negative 0.875. So maybe somewhere here. So let's put somewhere here is negative 0.875. Okay, so okay, more or less here. Okay, so we have this point here. Okay, so now when we connect those 2 points, okay, so we have somewhere here. Okay, just draw, okay, some sort of curve. Okay, so based on the previous slide, Okay, I've mentioned that the intersection between the curve and the x-axis is actually our root. Okay, so this is actually where our roots lie. Okay, but we don't know yet what is the exact value, but okay, it is somewhere between 1.5 and 2. Okay, so it means that in the next iteration, okay, when I equals 1, we are going to have A1. So our A1 now will be 1.5, okay, because we are going to choose the interval at the right. Okay, so we will ignore the interval at the left, which is 1 to 1.5. So in the second iteration, we are going to have A1 equals 1.5 and our B1 equals 2. Okay, so now we need to compute now the C1, which is A plus B over 2 again. So we have 1.5 plus 2 over 2. So now our C1 is 1.75. Okay, so similarly, we need to get F 1.5, but we already have the value at the previous iteration. So we just copy here. And we need to get F 1.75, okay, FC. So we put in the equation of F, okay, x equals 1.75. Okay, so we should get a 0.297. Okay, so check the stopping condition first. Okay, so we have F, the absolute of F 1.75 is 0.297. So this is still way greater than 0.05. So it means that we need to proceed. So we need to decide again, okay, in the next iteration, what is our A and what is our B. Okay, so look at the diagram one more time, but this time we are going to consider A1 is 1.5 and B1 is 2. Okay, so it's somewhere here we have 1.5 and let's assume this is 2. Okay, I make the scale bigger so that you can see clearly. Okay, so in between we have 1.75. So somewhere here is 1.75. Okay, when x is 1.5, so the value is somewhere here, which is negative 0.875. So we have this point. And when x is 1.75, the value is 0.297. So it should be at the top, at the positive part. Okay, so let's put somewhere here. So the value here is 0.297. So we have this point here. So similarly, we connect, okay, the two dots, okay, the 2 points. Okay, now, so you can see now, this is our intersection, okay, intersection of the curve with the x-axis. Okay, so if you compare with the diagram here, the roots is actually is not changing. The location is not changing. It's just that, okay, you see my scale is now I draw a bigger scale here, but it is actually at the same position, okay, as previous diagram. So now you can see the intersection is here. So it means that in the next iteration, when I equals 2, so you have your A2 now. So your A2, okay, should be 1.5 because in this iteration, you are going to consider the interval at your left-hand side rather than the right hand side, because we can clearly see that the intersection is in between 1.5 and 1.75. So our A2 should be 1.5 and our B2 is 1.75 now. Okay, so we repeat the same process. Okay, so we need to get our C2. Okay, so C2 is 1.5 plus 1.75 over 2. So by the calculator, okay, so you get the value of C2, and then you compute or you copy again the value of F1.5 is negative 0.875, and you need to get the value of the C2, okay, the value of C2 that you have here. So you find the value and you draw, okay, you draw again, okay, you draw one more time to see, okay, what is your value at of A3 and B3 at the next iteration I equals 3 and so on. Okay, so when I equals 3, you are supposed to be able to identify your new interval, okay, either the left side or the right side. So you find your A3 and you find your B3. Okay, and similarly you compute your C3 and so on and so forth. Okay, so you keep doing this process, okay, until you satisfy the stopping condition. Okay, so at the end, for this example, you should have until I equals 6 or something. I equals 6, you will get somewhere, okay, you will get your C6, which is 1.696, okay, and the corresponding F of 1.696 is 0.002, which is, okay, you can see the absolute value of F C6 is already less than 0.005. So it means that at that iteration I equals 6, you can stop. Okay, it means you have the solutions here. Okay, so at the end, okay, don't forget to write down your conclusion, to write down your root, okay, because our intention, okay, our aim is actually to get the value of x, okay, which is our root that satisfy our equation. So you put here, therefore, the x asterisk here, which, okay, implies our root that we wish to get, is approximately C6, your current value of C, which is C6, that is 1.696. Okay, so that is your solution, that is your root of the equation fx here. Okay, so this is the bisection method without memorizing the formula, the algorithm, but you need to understand how it works graphically. Okay, what it means by the A, B, where is C, what is the value of FA, FC, and so on. Okay, so that's all.